Welcome back to another lesson in physics. In this video, I'll be starting a series on electric circuits. Electric circuits are man-made, whereas static electricity is a naturally occurring phenomenon. The first thing we need to learn about electric circuits is to gain an understanding of voltage. Voltage is an electric potential difference. And what electric potential difference is the amount of work per unit charge that is placed in an electric field. It's the change in potential energy per unit charge. Electric potential difference is what we define as voltage, with 1 volt being equal to 1 joule of energy per Coulomb. In order to help you understand the idea of electric potential difference and what voltage is, I have 3 drawings here. In the first drawing, consider placing a positive test charge in an electric field that moves to the right. What this represents is an electric force field that it causes positive test charge to accelerate to the right. So in order to make this positive test charge move to the left, to move from A to B, you're going to have to do work. In order to make the positive test charge move to the left, you're going to have to do work. So this is what we mean by the idea of voltage. It's how much work you do per unit charge. You do work against the electric field, and by doing work against the electric field, you're going to gain electric potential energy. In the second drawing, I have an analogy to this idea of doing work against an electric field. Here I have the river current moving to the right. So you can say there's a steady current of about 10 miles per hour due east. And you're going to try to swim in the river against the currents. So you want to go from point A to point B. In order to swim against the current, your muscles, your body is going to have to do work. But once you get to point B, the river will cause you to flow naturally. Another analogy would be a waterfall. So here I'm representing the downward flow of water. If you would like for water to go from the bottom of the waterfall up to point B, you're going to have to do work against gravity, and usually that would involve a pump. So a pump would do work against gravity. Electrical circuits are all about the flow of charge and the loss and gain of electrical energy that accompanies this movement. Here I have drawn a simple circuit with a voltage source of 12 volts and 2 wires creating a closed circuit through a light bulb. As we study electric circuits, our voltage source is most often going to be a battery, where we're going to use chemical potential energy to create a voltage source. So the chemicals are going to do the work to cause charge to flow. Other voltage sources come from generators and solar cells. The role of the battery is to supply the energy, so it pushes the charge from a positive terminal to a negative terminal. As the charge moves through a circuit, so from point A here, the electrical potential energy is going to be turned into heat energy or light energy in this case. And by the time you get back down to the negative terminal, you're going to have used up all of your electric potential energy, and so there are going to be 0 volts going back into the battery. Inside the battery, there's its own internal circuit where either the chemicals or the generator or the solar panels are going to do work on charge to create this 12 volts. And the goal of the battery is to maintain a voltage source of 12 volts for the circuits. At the positive terminal, point A here, we say that the electric potential energy is a high potential because we're assuming a positive test charge. And so the positive test charge will move through the circuit, but as it does, it loses some of its potential energy as it goes through a load here, which we'll call an element. The element's going to either turn electrical energy into heat or light or sound or some other form of energy, depending on what element is being used. We say that there is a voltage drop across the load, across the elements. And so as the charge makes its way back down to the negative terminal, there will be 0 volts going back into the battery. So at this location of CD, we would say it has low potential. At location AB, there's high potential. At location AB, there's a high voltage area. Then you get a voltage drop across BC, and then you'll have this area CD of low potential, 0 voltage. Electric potential diagrams are convenient for representing the voltage at various locations in an electric circuit. So what this diagram shows that as you go from point D to point A, so as your charge goes through the battery, it's going to gain energy. It's going to gain 12 volts. And then as it makes its way from point A to B, it maintains a high potential of 12 volts. But then as it goes through the voltage load, it's going to drop in voltage. And so as you go from C to D, you have 0 volts. Here I have drawn another circuit. This time we're going to use a 6-volt battery as our voltage source. And so there's going to be 6 volts that will be used up in this circuit as we go from the positive terminal back to the negative terminal of the battery. Something else that's different about this circuit is that I have 2 light bulbs, 1, 2. And so we're going to show how the voltage goes through the wire to point B, and then there's a voltage drop as the electrical energy is used up to light up this bulb. And then you get to point D, and more of that electrical voltage is used up, so there's a voltage drop from D to E. And when you make it back to the negative terminal, you're back to 0 volts. And so you have high voltage, a voltage drop gives you medium voltage, another voltage drop, and then low voltage as it makes its way back into the battery. So here is the diagram that represents the electric potential. From point F to A, you have the internal battery circuit doing work to give it 6 volts. And from A to B, there's that high voltage of 6 volts. Then from B to C, you get a voltage drop. From C to D, maintains that voltage. But then as you cross the load from D to E, there is a voltage drop. And from E to F, it maintains that low potential. Thanks for tuning in. I hope you have a better understanding of voltage and the electric potential difference. In our next video, we'll be looking at electric current.